Hello everyone. In this video I'm going to talk about property attributes. In the third video of this video series I showed you some of the built-in Unity attributes. For example, the header attribute which takes a string as an input, or the range attribute which can be used to quickly customize how a float or int input field looks inside your custom inspector. Now, if you want to create your own attributes for used inside your classes, you can use property attributes. Every custom attribute that you are going to make will consist of two elements. The first element is a property attribute class in which you are going to define any input that your attribute is going to take. For example, the built-in range attribute takes two arguments, the minimum value and the maximum value. And the second element is a property drawer class in which we are going to define how the field just below our attribute is going to be drawn inside our custom inspector. Let's create a read-only attribute. The function of this attribute is to make any field that comes just below it non-editable. So you are only going to see the value of your field inside your custom inspector. You can't edit it. You can use it for your float, int, or string, or any kind of field. So you can just see it and not edit it. And the first step for that process is to create a C# script, and let's name it read only attribute. So this is the first step of the first element of any property attribute is to create a class which derives from the property attribute class. And since it is deriving from the property attribute class and not from mono behavior, we don't use the start and update functions. What instead we will have to write is a constructor for our read only attribute class. So inside that constructor we will define any input or any argument that our attribute is going to take. In this case our read only attribute doesn't need any argument, so we'll just write a empty constructor public read only attribute. So this is a simple property attribute which has zero arguments, and the next element of a custom attribute is writing its property drawer. We write our property drawers inside the editor folder. So let's come to our editor folder and create a C# script. Let's name it read only drawer. This property drawer class will function exactly the same like how we did in our previous video where we created a property drawer for our classes. So let's come to read only attribute drawer, and to make it a property drawer, let's first include the Unity editor which has the property drawer class, and for every property drawer we have to define that this is a property drawer of which class. So in our case this property drawer is of the type our read only attribute, and in all of our property drawers we just need two functions. The first one is public override on GUI where we define all our GUI elements, and then next one is the get property height which is used to override the height value, so you can change the height of your field. Our read-only attribute is now ready to be used inside our classes. But one thing to note here is that the serialized property that we receive from our onGUI function is not the serialized version of our read-only attribute. It is actually the serialized. This property refers to the field that comes just after our attribute. So I will show you an example inside the player script. Suppose we have a public float function called test, and just above it we have written our own attribute, the read only. So the read only is attached to the field or variable that comes right after it. So the the property, the serialized property that I'm going to receive here in my onGUI function will actually be this float value called test. Let's create another variable. uh, Let it be of the type int. So this is my int variable called achievement count, and let's draw it using the read-only attribute. So when we come inside our read-only attribute drawer, I will receive a reference to the achievement count int variable, and we can specify how we are going to draw it inside the onGUI function. Since we want to draw the int field as a read only, so we are only going to need the GUI dot label field, because we are only writing text, we are not making any input field. So the GUI label will take rect as an input, and we will draw it as the same position as the position we got from our onGUI function. And the content can be a string that is written inside that rectangle. So one of the things that you can do is create a label just before uh, just before your field, just like how Unity does for all the variables. So here you can see, first we have a label called player name, and we have the input field. So in this case, we can make the label to be property and name. Here we have two options. Property dot name will return the exact name of the variable. So in this case, it will return achievement name exactly what it is. But you might have seen or noted inside the Unity default inspector, sometimes Unity will do some customization to your variable names. So it will capitalize the first name, it will add a space when you are writing your variables like this. For example, in your player class, the actual name of your this field is player, and the n is capitalized and p is not capitalized, but Unity will add a little bit of formatting to that name and convert it to player space name, where player and name are both capitalized. So this is a little bit of formatting that Unity can do, and you can get that formatted name of your field by using property dot uh, display name. Display name is the formatted name of your variables. So you're free to use either the exact name or the displayed name for your properties. Oh, sorry, I should write this inside the GUI label and not in the get property height. So it was label, right? So now our GUI label will display the display name of our property, which is in this case is the achievement count in the place of a. So by default, Unity should have drawn a int field for our achievement count variable, but since we are using the read-only attribute, it will only show the name of the field. But we know the name of the achievement count variable is not enough. We want to see the value of our achievement count. Now we have two options here. If you already know the type of your property, as in this case our property is of type int, you can directly write your property and get the int value from that, and then convert it to string. This way, property.int value will fetch the int value stored inside your serialized property, and then we get converted to string. This is the easier way, and it will show you the value stored in this achievement count variable, and it's not editable, you can't change it, it's not an integer field. But if you want to use your read-only attribute for all types of fields, you want to use it for a float field, you want to use it for a string, etc., for that case there is still no way to directly convert the value of your property directly to a string. I don't know of any way to directly convert your property to a string value. So there is a little bit of tedious work here, is that you can get the type of your property. So first you have to do is find the type of your property, and then convert and get the value of that type from your property, and then convert it to a string. So I will show you how it's done. So first we write a if statement, property dot property type, and property type will the serialized properties have a very few defined types, like property of the type integer, property of the type float or bool, etc. So you can compare what is the type of your property that the read only attribute is going to be used upon, and then you can get that value using that type and then convert it to a string. So if the read only attribute is used just above an int, we can get the int value and then convert it to string. So let's save this in a string here. Let's define a string variable, string value, and every time we get a string value of the proper type from the of a proper type from the property, we will assign it to our value string. And instead of doing this conversion here, we will just write the value type, and this is sufficient if we are only going to use it for ints, and we can easily extend it for a float type or a string type, etc. So we'll write dot float type, and the only change would be that your property dot float value, and then we will convert it to string. Let's write one last one for a string type. Right, and since string is already a string, you don't have to convert it to a string. So property dot string value. Yeah, little typo here. Now your this read only attribute can be used on either an int field, a float field, or string. So let's test it inside our player class. Let's write three different fields: public float, achievement. Let's get a float, for example, average time, and let's also give it the read only attribute that we have just created, and the last one would be a string. So let's make a string variable called last achievement, and now we can see that our read only attribute will work on all of these three fields. So here we have a read only achievement count, which is an int, for float, and for strings. The next category of custom attributes are custom attributes that take some argument. For example, the range attribute for our float or int fields. And the process of creating a custom attribute which can take argument is exactly the same like we did with our read only attribute. So first we create a normal script of the type property attribute. So let's create a C# script, and let's extend our read only attribute so that it not only makes it a string, a read only string, but can also give it a color based on an argument. So let's name it read only with color attribute, and any argument that your custom attribute is going to take, you will have to define it inside the constructor of that property attribute. So your read only with color attribute is of the type property attribute, and when we are writing the constructor of read only with color attribute, So since we want to take the color value as an argument, so we can define three floats which will represent the red, green and blue value. So let's write R, G and B, and it has the variables, the internal public variables R, G and B. Public float R, G, B, and this constructor will simply copy these arguments to the internal variables. So R is R, G is right. So now whenever we are going to use the read only with color attribute, we'll have to specify these three variables. For convenience, we can make an empty constructor so that if the user is not willing to give any argument, we can give it a default argument. So let's write a constructor with no arguments. In this case, we will initialize our variables to let's make our default color to be green. So that will be R0, Z, 0F and B. Right. So if the user wants to give a custom color, he will use this function. And if is not bothered about giving a particular color, we will draw it by the default color, which is in this case is green. Now the second element for every custom attribute is the property drawer class. So we will make a new class called read-only attribute, read-only with color attribute drawer, and just repeating the steps from our last attribute drawer. We'll first derive it from editor, make it of the type property drawer, right, and then define the, and the type here is our new attribute, which is read only with color attribute, right. And then we will just simply override the two important functions, which are public override on GUI and public override, right. Now we are done. Since this will also draw a string for the fields, the only change is the color of that string, so we can directly copy paste code from our old read only attribute drawer inside our new attribute drawer, which is the read only with color. And the only change between these two values is the color with which we are going to draw our field, our string value, which represents the value inside our fields. So to change the color, we are going to use GUI.color method that I've talked about in my previous videos. So let's make a color field, which is the input color that we are getting from our attribute. So in order to get the values stored inside our attribute that the user has provided when we are writing the attribute inside our player class, the arguments that are associated with your attribute is stored inside a variable called attribute, which you automatically gets from your property drawer class. And to use it, you'll have to first create a variable of the type read only attribute, read only with color attribute, or any of the type that you have written your attribute. So which in this case it is read only with color attribute. Let's name it simply attribute, and we will have to make it equal to the internal attribute variable, which contains all the information about our attribute. And we only have to convert it to a proper type, which in this case is read only with color attribute type. From our attribute class we can create the color with which we'll draw our inspector. So input color is new color, and the values of this color we are getting from the attribute variable. So our attribute dot r Right. So our input color is exactly how our user has specified when he is going to use the our read only with color attribute. And with this color, we can simply make GUI dot color is equal to, and then we reset the GUI color, which is color dot white. Now, if we come to our player script, let's make a new variable called public string, and let's make a string called best achievement. Now let's give it a normal initial value, best achievement, and here we are going to use our custom attribute that we have just created, read only with color. Now we have two options. If we don't give any argument, it will draw it with a green color, or we can specify any RGB color with our read only with color attribute. So let's try to give it a red color, which is R1 G0 and B0, no, blue 0. And now when we come inside our Unity editor, we will have our string field best achievement with color red. And to test the no argument read with color, we'll just remove all these arguments, and now Unity will draw it with the default color, which is in this case is green. So in this video I showed you how you can create your custom attributes. These custom attributes are really helpful when you want to quickly customize the look of fields inside your classes, and you don't even have to give any effort towards writing custom inspectors. And these custom attributes are highly reusable. So you can use the same attribute over any field. You can use it in all of your scripts inside your project.